Hey guys, Mrs. Harbin here with another quick instructional video on Pre-Calculus Chapter 1. Today we're looking at Lesson 1.4, Right Triangle Trig. Now this lesson is going to be quick and easy, so it's a great lesson to make sure you understand all those trig ratios and can apply them. So there are times you're going to be asked to solve a right triangle, and all that really means is find the measures of all the sides and all the angles. That means 3 sides, 3 angles, using the information that you've been given. That's all it means to solve a right triangle. So let's take a look at an example. You have right triangle ABC here, and sides A is 3, side B and C are left up for you to solve. And we do know one other angle. In addition to this right angle, we've got 42 degrees. Now, by default, we could also figure out angle A as well, because we know a triangle adds up to 180 degrees. Some things that we're going to use to find these missing measurements, the Pythagorean theorem possibly, or even some of our trig ratios. So let's start with angle A. Angle A, we know that a triangle adds up to 180 degrees. Our right triangle, our right side here is 90. That means the other two sides have to add up to 90. So 90 minus 42 gives us 48 degrees. And we have figured out angle A. Not so bad, right? All right, what about side B? Well, to figure out a missing side, we need to use a trig value. In this case, we're going to do the tangent of 42. Since tangent is opposite over adjacent, we know that the side opposite of 42 degrees is side B, and the adjacent side is side 3. We could also do the tangent of 48, using opposite for 3 and adjacent for B. Either one of those would work. We can't use sine or cosine because both of those require the hypotenuse, which we still don't know yet at this time. So using the tangent of 42 and solving for B, we get B is approximately 2.7. So let's go ahead and write that in there. And now we know 2 of our legs. We're left to find the hypotenuse. What do you think we should do? We can use sine, we can use cosine. We're going to do the cosine of 42. And that's going to give us the ratio of 3 over c, or adjacent over hypotenuse. And solving for c, we get approximately 4. And that right triangle has been solved. All 3 sides, all 3 angles. So there is our final answer, 48, 42, 90, 3, approximately 2.7, and approximately 4. The angle of elevation is the angle that is formed by a horizontal line and the line of sight as the observer looks at an object that is above the horizontal. So let's imagine that here you are, you're standing here on the ground. Must be down in Georgia since we've got some red clay underneath our feet here. And you are watching maybe, I don't know, a hot air balloon. So this is going to be a very poorly drawn hot air balloon. And the angle of elevation is the angle that is formed by a horizontal line and the line of sight. So let's say that this is your initial line of sight. Looking at the balloon, you've got a nice horizontal line. And as the hot air balloon starts to go up into the air, maybe it goes all the way up here. Oh, this is an even worse hot air balloon than the first one. And now you have to tilt your head back pretty far to be able to see up to that hot air balloon as it has risen into the air. This is now your angle of elevation. Basically, how far back did you have to tilt your head to see this object? So you have your angle of elevation, horizontal line, and line of sight. The angle of depression is the angle that is formed by a horizontal line and the line of sight as the observer looks at an object that is below. So you're looking at an object, it starts to go down, and you tilt your head forward to follow it down. You are forming an angle of depression. So here you are, the observer. Can you think of anything that you would be looking at that would cause you to have an angle of depression? Maybe you're looking at a small child, a small animal, something that is shorter than you are. Or maybe you're watching a balloon descend as it runs out of air, starts to run out of air, and it descends. You're following it downwards. So there are lots of times in real life that we are using an angle of depression. Let's take a look at some bearing measurements. When we talk about bearings, we're talking about directions. Maybe you watched movies or listened to TV shows and you've heard maybe on a cruise ship like the Titanic, for example, bear right, bear left, 27 degrees, for example. They are using the Cartesian plane to help them navigate. So if we lay our Cartesian plane up on top of this, we've got our x-axis here and our y-axis here, and that corresponds with north and east, and then west and south over here on the other side of our x-axis. And so when we look at this, our direction of bearing, we were going in a straight northerly direction, but we had to go east 27 degrees. So we were north, and then we went 27 degrees to the east. And ships would use this to make sure that they avoid any collisions with any objects or any other ships. So our bearing measurement is north 27 degrees east. So here's another example for you using these angles of elevation, depression, and some bearing. There are two lifeguard stands located 100 meters apart on a north-south coast. One guard spots an oil derrick at a bearing of south 42 degrees 40 minutes east. If the oil derrick is east of the other guard, how far is it from the second stand? So anytime you're doing a word problem like this or a real life application problem, my recommendation first of all is to try and draw a picture. We know that this is going to be on the Cartesian plane, x and y axis, because we have this north, south, east, west. So we're looking at directions of bearing, not angles of elevation and depression. So let's go to this picture here and see if we can figure out what's what. I'm going to flip back and forth a couple times. All right, so we have two lifeguard stands located 100 meters apart on a north-south coast. So this must be lifeguard stand 1. I probably would have labeled it with lifeguard stand 1 and lifeguard stand 2. And here they are, 100 meters apart on the north-south direction. Let's go back and look at our next piece of information. One guard spots an oil derrick at a bearing of south 42 degrees 40 minutes east. If the derrick is east of the other guard, how far is it from the second stand? So this guy up here, at his bearing, he notices south and east, 42 degrees 40, an oil derrick. And it tells us that it's directly east of the second lifeguard stand. And our question is, if it's east of the other guard, how far is it from the second stand? So this is what we're wanting to know. So this lifeguard up here, he looks out, he sees something at a bearing of 42 degrees 40 minutes, and he's trying to communicate maybe with this other lifeguard stand number 2, how far away it is from the second lifeguard stand. So we're going to use one of these trig ratios to fill in our missing information. We know that tangent is opposite over adjacent. We have our adjacent, that's that 100 meters. So we're going to use the tangent of 42 degrees 40 minutes. X is our opposite over our adjacent 100 meters. We're going to solve for x using just algebraic steps and using our calculator here for that 42 degrees 40 minutes. And we find out that x is approximately 92.2 meters. All right, that takes us to the end of solving right triangles today. So hopefully you understand now what's meant by solving for a right triangle. Find all the sides, find all the angles using your trig values and possibly the Pythagorean theorem. And you've looked at angles of elevation, angles of depression, and bearing for some real life application of where these trig values can come in handy. If you have any questions, be sure that you ask them in class next time. See you guys later.